Okay, in this video we're going to talk about independence and conditional probability. Now remember that we say that two events are independent when neither event influences the other. That's what it means for two events to be independent. Neither one has an influence on the outcome of the other event. And typically, if we actually know what the events are, then it's easy to tell if they are independent. For example, rolling a die and drawing a card from a deck of cards. Those two events are independent because neither one of them has any influence on the other event. Well, if you don't actually know what the events are, like for example, say you're just talking about event A and event B, and you don't know what event A and event B refer to, well, then if you have some information about the probabilities of those events, then very often you can still determine if those events are independent. For example, there are basically three tests that you can use to tell if events A and B are independent. The first one is the probability of A and B, the probability of both events happening together, is that equal to the probability of A times the probability of B? Now, you may remember this thing that we've looked at called the multiplication rule, which is usually written like this. Probability of A and B equals the probability of A times the probability of B given that event A has already happened. So this is called the multiplication rule. And notice the way I've written this, I've basically kind of chopped off this part over here. Well, this is just a way of saying that, well, if the probability of A times if the probability of A and B, if that equals the probability of A times just the probability of B, well then you know A and B must be independent, because in that case the probability of B doesn't depend on what happened in event A. Right? So this is one test that you can do to see if event A and event B are independent. Here's another test. Is the probability of B, given that event A has already happened, is that equal to just the probability of B? If the probability of B, given that event A has already happened, if that's just equal to the probability of B happening without any regard to A, well then you know that the two events, A and B, are independent. In the same way, if the probability of A, given that event B has already happened, if this is equal to just the probability of A, well then you know the two events are independent, because the probability of A happening, given that B has already happened, it doesn't make any difference. That's just equal to the probability of A. So these three different tests, you can say, this is how you can determine if two events are independent, even if you don't actually know what the events are, and all you have are, say, some numerical probabilities. Now, if you can answer yes to any one of these three questions, then event A and event B are going to be independent. And notice that you only need to verify that one of these three statements is true. If one of these statements is true, then all are true. Now, remember that the multiplication rule, which is written like this, probability of A and B equals probability of A times probability of B, given that A has already occurred. The multiplication rule can be used to determine the value of these three values here. Probability of A and B, the probability of A, or the probability of B given A. In other words, this formula, if you want to think of it as a formula, this is just a formula that's kind of like x equals y times z, where this is x and this is y and this is z. Well, if you happen to know two of these values, any two of these quantities here, x and y or x and z, you can find the value of the third quantity. It's the same way here. This is just a formula that has these three quantities. If you know any two of them, then you can figure out the value of the third one. In the same way, the addition rule, which you remember is written like this, probability of A or B equals probability of A plus the probability of B minus the probability of A and B. That's the overlap part that we talk about. Well, notice the addition rule can be used to determine the value of each of these four pieces of this formula. Probability of A or B, the probability of A, the probability of B, or the probability of A and B. And again, this formula is really just kind of another way of writing, say, for example, W equals x plus y minus z. And again, if I knew the values, like if I had numerical values for, say, w and x and y, well, then I could plug those values in and I could find the value of z. It's the same way here. If I know my addition rule, and if I know the value of this quantity, and I know the value of this quantity, and I know the value of this quantity, well, I could plug all those in and I could find the value of this quantity. And notice that I can do that even if I don't know anything about what event A and event B actually are. If all I have is numbers, if all I have is numerical values for these, I can still come up with a numerical value for any one of the missing pieces of this formula.